last video, we talked about the limit of a function at a point, okay? And then we found the limit of a function at a point by using graph, right? If you are finding a limit of a function, let's say fx at the point A, what we did is we draw the graph and then we look at the height of the function close to A towards the left and check the height. And then you find out the height of the function close to A towards the right side and find the height. If the height on the left side and the right side are almost equal to a number L, then L is called the limit, okay? That's how we find out from the graph. And from the chart, what we did, we plug in the different points on the left side, and then we plug in the different points for x, different values of x towards the right side, and then you check the height or find the value of fx. And if they are equal to each other, then we say that L is the limit. Also, we did the epsilon delta definition of the limit, and epsilon delta definition is used basically to find out if you want to be within epsilon distance from L values, then how close should you go to the A values is the delta distance, right? And then sometimes you will be asked to find out delta. If you want to find out delta such that fx is within epsilon distance from L, then you start with absolute value of fx minus L less than delta, and then you simplify this, you plug in the value of fx, okay, and then plug in the value of L, plug in the value of epsilon, and then simplify this and then try to get x minus A less than delta. So and then whatever value you get here will be the delta value that you are interested to find out. That's what we did in the last video, okay? On this video, that is section 1.3, we find the limit analytically. What does that mean? Meaning that the way of finding the limit using the chart or the graph is not easy. It takes a long time, right? It has a lot of work. But we don't use this method to find out the limit in general. What we do is, if you are trying to find out the limit of this function, for example, what you do, you plug in that limit x equals to 3 here. And then it is basically similar to or same as finding the functional value, okay? So what we do, you plug in that 3 on here. So how do I find out this limit, for example, is you do 4 equals to 4 times x squared is 3 squared. I'm just plugging in x equals to 3 plus 3 times 3, right? And then plus 5. So how much is that? 4 times 3 squared is 3 squared is 9, right? So 3 squared is basically 9. So this is 9. 4 times 9 is 36. And this is 9. 36 plus 9 is 45 plus 5 is 50. So 50 is the answer there. You see that? Okay, so basically to find out the limit analytically, you just plug in the limit, plug in that x value into the x there. And whatever number you get, if this number is finite, like 0 or minus 5, 10, 20, 50, like that, a finite number, then that is the answer. Sometimes when you plug in the limit, plug in that number, you get infinity. In that case, we say the limit does not exist, okay? Or sometimes we get 0 over 0, okay? In that case, you will have to do some more work before you plug in the limit. All right, so I will give you that type of example later, but for now, just keep this in mind. If you are finding the limit of a function, you plug in that value into that x. You plug in that limit value into the x, okay? Let's do another example. Limit x tends to, let's say, -2, okay? X tends to -2, x squared over x minus 4. How do I find out this limit? Again, just plug in that -2 square over -2 minus 4. You see that? What is -2 square? That is positive 4, right? Because it is -2 times -2, right? So negative is positive, 2 times 2 is 4. That's what you get. So over -2 minus 4 is -6. Now you simplify that, divide by 2, what do you get? Equals to -2/3. I put that negative sign in the middle. You can put it in the denominator or numerator or in the middle, so it doesn't matter. Okay, so the limit of this function is -2/3. But graphically, what does that mean? That means if you are close to -2, then the height of the function will close to negative 2/3. That's what it means. That is below the x-axis because it is negative, right? All right, let us do this example. Let fx is 2x squared minus 3x plus 39 and gx is cube root of x plus 5. Now what you want to do is you want to find limit x tends to 4 fx. How do I do that? It is limit x tends to 4. Fx is just plug in that values, 2x squared minus 3x plus 39, right? Now you plug in 4 for x. So you will get 2 times 4 squared, right? Minus 3 times 4 plus 39. You see that? So how much is that? 2 times 4 squared is 16, right? So 16 times 2 is 32 minus 3 times 4 is 12, right? So 32 minus 12 is 20 plus 39 is 59. That's what you get. Here I just replace the value of fx. I just put the value of, write the value of fx, limit x tends to c, 2x squared minus 3x plus 39 over 12. Now we replace x by c. So 2 times c squared minus 3 times c plus 39 divided by 12. That's it. We cannot simplify further. And here there is a composite, right? G composition fx. You see that? So what you do, you just plug in the value of fx first, write the value of fx, limit x tends to 4. G is still there. I plugged in the value of fx is 2x squared minus 3x plus 39. Now what you do is you write the limit inside. You replace x by 4 there. G is still G, right? 2 times 4 squared minus 3 times the 4 plus 39. You see that? So how much is that? It is basically G. 2 times 4 squared minus 3 times 4 plus 39 is 59, right? 59. Now you replace x by 59 in the function g. You see that? That is the function g. So what you do is cube root of 59 plus 5. You see that? How much is 59 plus 5? 59 plus 5 is 64, right? And what is the cube root of 64? Cube root of 64 is basically cube root of 4 times 4 times 4, right? So since there is cube root and there is a product of 3 4s, so the answer is 4. So cube root of 64 is 4. You see that? So now the last one is there is 5 times gx squared, but there is limit. I should not forget the limit there. So let me write down limit x tends to 4. There is 5 times gx squared. Okay, so gx is how much? Cube root of x plus 5 and then square. So you can write the limit directly inside. So how much is 4 plus 5? So 4 plus 5 is 9, right? Cube root of 9 square. That is basically 5 times cube root of 9 and then square. You see that? So how much would that be? That is 5 times. Do you know how to write a cube root of 9 in the exponent form? I would write this way, okay? So this is 9 to the 1/3 and then square. You see that? Because whenever there is a cube root or square root, there is 1 in the exponent of 9, right? That number inside that angle, inside that root angle, goes in the denominator of the exponent. So 9 to the 1/3. Okay, how can you write that 9? Can you write 3 to the square? So it is like 5 times 3 to the square times there is 1/3, because 3 squared is 9, right? Times there is 2, because that square is 2. So ultimately you will be able to write this as 5 times 3 to the 4/3. That is the final answer. But be careful, you cannot multiply 5 and 3. Why? Because 3 has exponent 4/3, 5 has exponent 1. They have different exponents, so you cannot multiply. So the final answer is 5 times 3 to the 4/3. That is the final answer.